Welcome back, and today we'll be doing preview assignment part 3C. How much does our, and it's titled 3C, how much water does our class drink? So 3B was how much water do you drink? 3C is how much water does our class drink? So should be putting together your data for that one. So let's take a look at it. Yeah, let's give me a second to size it. Okay, here we go. So today, in this preview assignment, where we will use correct symbols for mean and standard deviation, between population and for samples. And read values from technology for mean and standard deviation for populations and samples. So first things first, let's look at symbols. Maybe recall from previous course that we are often interested in the center and the distribution of data. 3C, how much water does our class drink, begins here. Notice what we have here in the picture on the right is a normal distribution. Starts low, peaks, and then falls off in a very symmetrical fashion. Symmetrical means if I was to go where the mean is, fold that sheet of paper in half, they would fold exactly on top of each other. And note that we have two items on here. We have the mean, and we have standard deviation. Now, standard deviation is a equally spaced division going to the left and the right of the mean. And later we're going to learn what does one standard deviation plus or minus mean? What does two standard deviations mean? What does three standard deviations mean in terms of the area on the curve? That's later. See, one way to measure the center of a data set is by calculating the mean. Well, the mean is basically two items. We have two letters we use. We use a Greek letter pronounced mu, and that is the mean of the actual population that we're looking at. Then we have X bar, which is basically the American letter, Arabic. I think it's Arabic. X bar, which is the mean of the sample of the population. So mu is the mean of the actual population. X bar is the mean of the sample that you took from that population. And we have standard deviation. Standard deviation is an indication of the spread, how either tight the data is or how spread out the data is. So the mean is the center, or it could be X bar, and whether it's real tight or not very symmetrical, but or spread out, is defined by your sigma. Sample deviation is designated by the letter S. Okay. Sample S. Population sigma. Population Greek. Standard deviation of the sample is just a letter. So let's see, we have mu and x bar, sigma, and S. Population, sample. Okay, so for each item, select the correct answer from the list. The following question is designed to test your knowledge of the symbols used in statistics. Each symbol is defined on the previous screen. Notice that English letters denote numbers represents a sample. Again, English letter, sample, Greek letter, population. So, mean of a sample. So that means we immediately eliminate the Greeks. Okay. Then we have to just determine between X bar or S. And of course, it would be X bar. Which finally represents the population standard deviation. Okay, now we're talking about population, so the regular letters we eliminate. So it's going to be mu or sigma. Standard deviation, sigma. Again, population. So we want to be looking at the Greek letters. And if we just said that from the previous one, this is standard deviation. So mean has to be the other guy. And again, sample, so immediately the Greek can be eliminated. We know this guy is the mean from a previous problem. It has to be S then. Oops. Usually not possible to collect data from an entire population, so samples are used to represent the whole population. Lesson 3, part A and B, discuss inference and using measurements obtained from a sample to draw conclusions about a population. We also have the central limit theory, allows us to use the means of a large group of representative samples to create a normal distribution with a mean that approximates the mean of the population. Boy, is that's a mouthful. Go back to view 3A and 3B if you need to. Caution, central limit theory does not mean that we have to always take a lot of samples. That method could also be difficult or expensive. Okay, so the video about mean and standard deviation. The height of the player of a volleyball team illustrates how the spread of the data point affects the standard deviation. If data are more spread out, the standard deviation is relatively large. If data are closer to the mean, standard deviation is relatively smaller. After watching the video, follow the directions on the next screen to practice with the applets.
Exploring standard deviation. This dot plot displays the heights in centimeters of the mid.
Okay, this is an 8-minute video, so I'm going to put it on pause, another screen, pull up this tutorial, and watch the video. Okay, you got me off pause. That means you must have watched the video. Hopefully you got some good information out of it, because the next screen is going to be the applet with us doing some of this stuff. Okay. Again, in recap, okay, the further away standard deviation is a measure of spread, or how far away that some data points are from the mean. As you bring the data that's far away in closest to the mean, you're going to decrease your standard deviation. Big picture. Okay, so let's open the applet. And let's see, interact with the volleyball player's height applet to generate answers to the questions below. Let's bring it up again. Okay, here, this is volleyball player's heights. The mean of 174.6 and standard deviation 6.4. Of course, you can move your points around and see how the mean is changing as this approaches the mean. The standard deviation reduces. Same difference. Notice that little green arrow represents the mean, and the length of blue is plus or minus 1 standard deviation. So let's go back to the other screen. See what question A says. Click reset to ensure you have the original data. What is the mean and standard deviation of the Midwestern State player's height? Okay, let's go to reset. All right. So mean, 174.611, standard deviation 6.4. It's 174.611, 6.4. Okay. That was just reading it right off the screen. Part B. One player height is 180 centimeters. If she gets injured and is replaced with a shorter player, which of the following describes what would happen to the mean height? Okay. So she's tall and she's replaced by someone who's shorter. So would that make the mean get larger, smaller, same? Depends on how short the replacement player is. So here's 180, and let's just say this person gets replaced by someone who's 170. So let's see what happens. It gets smaller. I'll tell by watching the green. As I move this person down, what is that green arrow doing? It is getting smaller. So it's going to drive down the mean. B. The mean will get smaller. Let's see what C is. One player height is 180, gets injured and is replaced by a shorter player, which the following describes what would happen to standard deviation. Why? Standard deviation will get larger, standard deviation will get smaller, standard deviation stays the same. With D, it depends on how short the replacement player is. Well, let's find out. Reset. Let's take a 180. And let's watch standard deviation as we get smaller. 6.43. Okay, it's getting smaller. Now we're back to mean. Now it's going back up again. Let's see, try this again. Let's reset. We're at 6.4. when A got injured, and depending on now someone if he person replaced with someone who's taller, goes up. Okay, and keeps going down until you go until you basically at the mean, and once you start going past the mean, it starts going back up. So A gets larger. Well, if it's replaced by a taller person. Standard deviation gets smaller. Yes, as you start approaching the mean. Standard deviation stays the same. Again, depends on what the height of the person is. Depends on how short the replacement player is. I'm going to go with D. And we proved this. So we proved that button. Keep hitting the wrong button. Prove that. Like I said, just by moving this guy around and just watch what happens. Click reset and return the original data. Now click add point. Okay. Reset. Add point what? Add a new player at 174.611. That is the mean. .611. Okay, now watch these numbers. Mean did not change, but the standard deviation went down from 6.4 to 6 point, almost 6.2, almost out of 0.2 centimeters, because we added weight to the center. What happens to the mean? Stay the same. What happens to standard deviation? It went down. Why do you think this happened? Record your answer and justifications in your notebook and bring it to the next class. This is an online class. That's going to be hard to do. Did it again. Long story short, a standard deviation is a measure of how far a point is from the mean. If you're right at the mean, the contribution of deviation by this point, right at the mean, is 0. There is no contribution. So because of no contribution, it's going to bring down the overall standard deviation. If I add another point, exactly the same, now think about it. Once I add that, what should happen to the mean? It shouldn't change at all. It should stay the same. Standard deviation, I add another point that has absolutely 0 weight, 0 additional deviation, but it adds weight to not being away from the mean. So it should go down. Yep. Mean stayed the same, standard deviation went down. It's hard to fully explain without doing the full-blown equation. What's next? Okay, earlier you worked with an applet that showed a normal distribution, a right skewed distribution, and a left skewed distribution. I think I had an applet for that one. The image at the right shows a uniform distribution. Okay, if you say so. In which all the values are evenly distributed across the range of value. Okay. Also, what part A says. What is the mean and standard deviation of the population? Oh, uniform. Okay, not normal. It's a uniform distribution. Basically, that's it. Basically, no matter where you are, it's the same value. So the mean is 25.5, the median is 25.5, the standard deviation is 14.7196. 25.5, 14.7196. Reading it right off the graph. Now, which of these images represent 100 samples mean, and which represents 1,000 sample mean? How do you know? Record your response in your notebook and bring to the next class. 100 sample mean. And 1,000 sample mean. Okay. See, it's uniformly distributed. The more samples you take, sampling you do, the more you're going to approach a normal distribution. And between A and B, they were both sample size of 10. So essentially, one of these is 100 samples of 10, and one's 1,000 samples of 10 samples each. So which of these two look more symmetrical in terms of a normal distribution? Okay. This was not quite, it's approaching normal, but not there yet. This one is definitely more approaching of a normal distribution, where you would this one's not quite there yet. So I would say A is the 100 sample and B is the 1,000 sample. Means 25, 25.5, 25.3, 14.7, that's irrelevant. 21.5, 25.4. Doesn't move with it. There's a formula, somewhat complex, for standard deviation. Calculate the distance between each data point and the mean of the data. Squares each of these numbers, averages them all together, and then takes the square root of the results. We will have to perform the actual calculation for standard deviation in this lesson, but we will be using standard deviation values to analyze our data. Basically what it's saying is standard deviation there's the equation. That's what they're saying. Calculate the distance between each data point and the mean, squares them, adds them all up, and averages them all together, and then takes the square root. Between you, me, and the wall, I either use a calculator or Excel to help me with these calculations. Although up to 5 to 10 you can do by hand. It just takes time. Okay, it says now print this normal curve and place it in your notebook. You don't need to do that. It basically just says draw vertical lines at each hash mark shown on the graph. It means hash mark, vertical line. basically plus 1 sigma, 2 sigma, 3 sigma, minus, minus, minus. Oops. Meant to hit the button. So confidence. How confident are you to use correct symbols? I'm very confident. How confident you can read values from technology? I'm very confident. All right. And I think that's it for 3. Okay, complete the tutorial. Now it's time to do the questions. And once that's done, it's time to do the preview for lesson 3. This was lesson 3. This is what we did. Percentage of holes, poles, samples, mean, average, central limit theory, terminology, and letters for mean and standard deviation. And I'll see you shortly where we'll go over the questions for the tutorial for 3C.